2, 6, 18, 54, and then continuing. Notice for this one, there is no common difference. So since there's no common difference, this is not arithmetic. So here I'm going up by 4. Here I'm adding 12. Here I'd have to figure that out. But we could see that it's definitely not a common difference. But there is something that they do have in common. Notice that if I multiply 2 times 3, I get 6. And 6 times 3, I get 18. And 18 times 3, I get 54. So this time, instead of a common difference, we have this common multiplier. But actually, we're going to look at it a little different way. Instead of looking at it as multiplying to get to the next one, if I were to take the 6 and divide by 2, so the second term divided by the first term, I get 3. And if I took the third term and divided by the previous term, I get 3. And if I take the fourth term and divide by the third term, I get 3. So what we're going to call this is we have a common ratio. So when we did arithmetic sequences, we had a common difference. With this type of sequence, we're going to have what we call a common ratio. And this is how you can actually verify if a sequence is this type. And what that type is called is a geometric sequence. So in a geometric sequence with a first term a sub 1 and a common ratio r, the nth term a sub n is given by this formula. So to find the nth term, you take the first term and you're going to multiply by whatever that common ratio is raised to the n minus 1 power. Now we actually did this when we first introduced in Algebra 2, when I first introduced exponential functions to you. We had that problem with I forget what I named this eccentric uncle, but you had this idea of doubling. So we started with a penny and then we doubled it and doubled it again and doubled it again, and that actually follows a geometric model. So let's look at an example to find the nth term of a geometric sequence. Suppose that you receive a gift on the first day of each month of a year, starting with $50 on January 1st, with the amount doubling each month, so kind of similar. How much will you receive on December 1st? So what we learn from this is our a sub 1 value is 50 because that's our initial term, and it's doubling each month, so that's my common ratio. It's going to double each month. So if I want to know how much I would receive on December 1st, we'll notice that that means that n equals 12. So we're going through all 12 months. And I want to know how much that he would receive just on December 1st. So we're not looking for the total amount accumulated throughout the year, but just on December 1st. So if we want to find a sub n, so that's a sub 12. So I take a sub 1, the formula is right here, so I take 50 times r is 2 to the n minus 1, which would be 11. And we can grab our calculator here, maybe. So if we take 50 times 2 to the 11th power, that kind of sounds nice. So how much will you receive on December 1st would be $102,400. If you remember, when you're doubling, it can get really big really fast. All right, next example. We are asked to find a sub 5 and a sub n for this geometric sequence. So I always start with my formula that I'm looking for, or that I'm going to use. So a sub n equals a sub 1 times r to the n minus 1. So our sequence, we know a sub 1 is 6,400, and I need to find r. So I can find r, remember, by taking 1,600 divided by 6,400. Notice it's getting smaller, this numbers in the sequence. So if we divide this we get 0.25, which is 1/4. And it really doesn't matter if you use the 1/4 or the 0.25. I typically use the fractions. So now you could verify this because it's always a good idea. Now they told us it was geometric, but sometimes you don't know that. And you want to verify by doing 400 over 1600 and verify that you also get the same thing. So this is to make sure it's a common ratio. So we have our common ratio and we need to find the nth term. And so we can actually come up with, well, we can find the fifth term. We'll do that first. So to find a sub 5, we're going to take a sub 1, so 6,400 times 1/4 raised to the n minus 1 power. So in this case, n is 5. So I'd be raising it to the 4th power. So we have 6,400 times 1/4 raised to the 4th power. And I get 25. So then when it asks me to find a sub n, that's just the formula, but plugging in what we know. So to find a sub n, I take 6,400 and I multiply by 1/4 raised to the n minus 1 power. Get in the habit of putting parentheses around your value of r. There's sometimes where you absolutely have to have it or you'd have a wrong answer. There's other times where, you might get away without having it and it'd still be right, but unless you are really sure when to have it and when not, just always get in the habit of doing the parentheses. All right, for the next example, we are asked to find r and a sub 1 for the geometric sequence with a second term of -18 and a fifth term of 486. Now, we don't know the first term. We know the second term is -18. We don't know the third term. We don't know the fourth term. We know the fifth term is 486. So, and we don't know r. So we have to do a little bit of, I guess, kind of detective work to figure this one out. I know that if I multiply -18, so just the relationship between -18 and 486, if I multiply -18 by r, I'm going to get this value right here, which is a sub 3. So a sub 3 is going to be -18 times r. Well, then this one right here, which I can think of as a sub 4, is going to be -18 times r squared. Because I multiply by r to get this, I multiply by r again to get this, so that was r squared. And then to get this term right here, which is a sub 5, I would take -18 times r to the third. Okay, now -18 is not the first term, it's the second term, but the relationship between those still holds. So this right here is going to be helpful now. So I'm going to take that. I get a sub 5, which is 486, so I'll substitute that in, equals -18 times r cubed. Well, now I can divide both sides by -18. And we get that r cubed equals -27, which then if I take the cube root of both sides, r has to equal -3. So now that I know that r is -3, it's easy to go backwards now. If I know this is -18, then I divide, so a sub 1 has to be -18 divided by r, so it would have to be 6. So this would have to be a 6 right here. So a sub 1 equals 6. We were asked to find a sub 1 and r, so that would be, that would answer our question. So not really a straightforward use the formula. You had to kind of understand how the formula is working and just a little bit of pattern solving. So that is actually it for our examples on geometric sequences. You have an assignment to work on, and then next up we will talk about geometric series and something called infinite geometric series.